So a few notes up above the title, because the whole unit is called conic sections, and most of the time, students, we immediately jump into the details of circles, hyperbolas, ellipses, and we sort of miss the big definition of what a conic section is. And conic sections are shapes formed by the intersection of a plane and a double cone. Shapes formed by the intersection of a plane with a double cone. Here we go. So we take our double cone, or at least part of our double cone, and we slice it straight across. What shape did that make? A circle. I take my, get out a knife. This would be fun. And this is actually what some people do. Math teachers who are, more invested than I am, build a double cone, take a knife and literally slice it across and be like, look, it's a circle. Do you know what would happen if we sliced a cup at an angle? A slanted circle, an oval, and what's the fancy name for an oval in a math class? A slanted circle.
An egg.
There it is, an ellipse. It'd be an ellipse. Which is an oval, yes. The others are a little bit harder to visualize. If you sliced it, here's our double cone. Here's my plane. If I sliced it just like this, like across this way, that would make, it would make a shape up here and a shape down here. Do you remember what that's called? It starts with an H. Is it on the board? It's on the syllabus or the calendar. On Friday, it makes a hyperbola. It's a little harder to draw. If you take your intersection so that it only slices one of the cones and it doesn't hit the other cone, so it's only like you have one branch of the hyperbola, that would be a parabola. And then there's some weirder shapes that you can get if you cut it at just the right places. So let's say also hyperbola, parabola. Those are the ones we'll worry about. But also you could get a point. That one's maybe not too hard to see. If you cut it right where the cones met right there, you'd have a point. So that's not much. There's not much to do with a point, so we don't talk about that very much. You could also get two lines. Like if you cut it up and down right in the middle. And then you can also get one line if you cut it at just the right spot. One line is if the plane is like tangent to the cup. It doesn't really intersect, it touches it at one line the whole way. We're not worried about kind of the weird cases. We're going to look at more of the normal kind of cases. Circle, ellipse, hyperbola. All right, standard form for the equation of a circle. X minus h squared plus y minus k squared equals r squared. H and k is the center, r is the radius. Okay, this is not going to be given on the test, but the test is multiple choice. So you'll see enough of those type of equations that I don't think you need to go home and memorize those. After we see the ellipse and the hyperbola, we'll look at all three of them and talk about how to recognize the difference between them. And it's not too difficult, I don't think. So we'll worry more about that when we get there. So not given, but I also don't think you have to go home and specifically memorize that, because you'll see enough of them on the test that you'll be able to recognize what's going on. All right, find the center and radius of, so example 1, the center and radius of that circle. The only thing you kind of have to be careful about is that the signs change. So the center would be at 5, -8. And the number on the other side is r squared. So r would be 4. So I think fairly straightforward today for most of it. There's one little trick that's coming up in a little bit. On number 2, Morgan, what's the center of number 2? Gabe, how about the radius? R squared is 4, so r is 2. There you go. Numbers 3 and 4 are sort of backwards problems, meaning we're giving you the answer, we want you to write the equation. If the center is 4, 9, so that would be x minus 4 and y minus 9. But don't forget, you still have to match the format, so it's x minus 4 squared plus y minus 9 squared equals 64, because it's r squared on the other side. Number 4, x minus 0 squared, which means you don't really need to write x minus 0, but some people will write it to sort of emphasize that 0 is the x coordinate, plus y plus 4 squared equals, what do we get when we square the square root of 7? 7. Okay, so those are pretty easy. 5 and 6 are where we get a little bit tricky, because find the center and radius, but it's not in the right format. Right? When it's in the right format, you can just look at the equation and just pick off the x, the y, and the radius. But this doesn't look right, and so job number 1 is to make it look right. So let's rearrange things a little bit here. Let's group the x's and group the y's and move the 11 out of the way. And now we want to make it look like the equation of a circle. Anybody know what we're going to have to do to make this work? One person figured it out first period. I would like my answer to look like that, right? That's where we're headed. I would like this to be a square, but it's sort of incomplete up here. There you go. Complete the square. To complete the square for those. And to me, the biggest, I don't know if biggest is the right word, most important part of complete the square is the HSA. Do you remember what HSA stands for? Half it, square it, add it. Half it, square it, add it. So for the x stuff, When we say half it, half of what? Do you remember? Half of b. So b over 2 is -3. Square that, we get 9. So we'll add 9. That completes the square on the left. But I can't just add 9 on the left. That wouldn't be right. So I have to add 9 on the right as well. So half it, square it, add it. And then we'll do the same for the y stuff. So half of b is 4. Square it to complete the square. So plus 16 on both sides. And we're almost there. Now we need to factor the two pieces. But factoring isn't like factoring we have to figure something out, because the factor is always whatever b over 2 was. So x minus 3 squared plus y plus 4 squared. And then on the other side, 20 plus 16 is 36. Now we can find the center and the radius. I mean, that's the easy part. 3, -4. With the radius of 6. So half it, square it, add it, and make sure you answer the question. All right, why don't you try number 6? Group the stuff, then do half it, square it, add it. So half it, square it, add it for the x stuff, half it, square it, add it for the y stuff, and then you're good. Then it's just picking off the pieces for the center and the radius. Square root 11 is the best answer. If you had to graph this one, you would know that that's between 3 and 4, a little bit closer to 3, and that's, on the graph, you couldn't tell the difference anyway. Speaking of graphing, let's go to the next one. Number 11. Sketch the graph of each circle and give its domain. So let's not forget to do the domain when we get to the end of this. So I need the center and the radius. I bet Parker can give us the center of that circle. Yes. And Isabella, how about the radius? 4, yes. So we'll go to 2, -3 for the center. And then we'll just go 4 in each of the main directions, up, down, left, and right. 4 away from the center. And then what shape are we graphing? Circle. So don't graph a diamond there, right? You only got 4 points, but it's a circle. So as best you can, don't just play connect the dots here. Try to put a nice circle in there. And I'm not going to take off for how neat and nice your circle is, unless you really do just, if you do that, I am going to take off a point or two, because that's ridiculous. No. Get out the compasses and, draw the circle around. Okay, domain, that would be the x values. And I don't think I want to pull up popsicle stick. We haven't done a domain question in a while. Somebody want to tell me what the domain is for that circle? Left to right. What x values does it cover? -2 to 6. Parentheses or brackets? Brackets, because we want to include -2 and 6. All right, let's skip B because it's the same stuff and the graphic is not too hard. Let's go to C. the only near trick, almost trick on C is what the center is. Well, people who aren't here yet, or aren't here. Christian, how about the center for 11C? But it's not just 6, because it needs to be an ordered pair. 0. And that 0 is the only thing that's kind of tricky, because there's nothing there, which means there's kind of a 0 there. So 6, 0, radius of 2. So over to 6, 0, and then 2 in each direction. Borrow a compass from Gray to get the circle just perfect. Beautiful circle. And then the domain. Xander, how about the domain of that one?
I couldn't figure out the domain.
Okay, so the domain is the x value, so that's the left and right. How far left does it go? How far right does it go? So what's the x value of the leftmost point? And the x value of the rightmost point, how far right does it go? 8. So 4 to 8 is the domain. All right, that's it for today. The rest of the worksheet packet is for later days. Today's assignment is worksheet 1, which I'll give you right now.